Hello and welcome to homework 7.015. All right, this is our second look at using substitution to solve systems of equations. All right, so let's see what we have here. Number one, using substitution, find the intersection points of the two lines. All right, so this one is one of the shorter ones because you're going to see they already have the y by itself. In fact, both equations have the y by itself. So it means we have even less work to do on this one. But y equals 3x minus 10, so we're going to circle the 3x minus 10 because that's what the y is equal to. And then we're going to take it and we're going to substitute it down into our other equation. So y equals 3x minus 10, we circled 3x minus 10. That's what's going to go in this second equation. So now I have 3x minus 10 equals 6x minus 25. All right, that's my combined equation when I make my substitution. Now I need to solve this. Again, I'm going to move the smaller variable. Don't get confused by this minus sign. This is still a positive 3, so we need to subtract 3x from both sides. We're left with a negative 10 equals 3x minus 25. We're going to add 25 to both sides. Get 15 equals 3x, and then divide by 3, divide by 3. X equals 5. Okay, so now that we have our first value, we still have to go in and find our second value. We don't just stop at x equals 5 because we also need to know y. So you pick one of the two equations. Again, it doesn't really matter on this one, so I'm just going to go with 6x minus 25. And then we're just going to do another substitution. All right, this time we're going to substitute in for x. So we're going to get y equals 6 times 5 minus 25. Y equals 30 minus 25. So y just equals 5. All right, so again, if we had two lines, and we don't actually have the lines because we're doing it algebraically, but if we had two lines, those lines would be intersecting at the point 5, 5. That's what we're doing here when we go through this whole process. And if you want to check it, you just break out your calculator. You go to the y equals menu, and then we can type in 3x minus 10, and we can type in 6x minus 25. Doesn't matter which one's on top, which one's on the bottom. Go to second graph, and then we just want to look. Yep, when x is 5, y1 and y2 are both also 5, so our answer checks out. All right, let's take a look at the second one. This one's a little harder. Using substitution, find the intersection points of the two lines. All right, now what you're going to notice about this one is, unlike the last one, we don't have a letter by itself. This x has the 6 next to it, this y has a 3 next to it, this x has a 4 next to it, this y has the negative sign in front of it. We don't have a letter that's just all by itself. So before we can do our substitution, we need to get a letter by itself. And the hint is, first solve the top equation for x. And the reason we want to do that is because that x has a positive 1 in front of it. We don't write it, but that's the number that's there. And the positive 1 is the best case scenario because when there's a positive 1, we don't actually have to divide anything when we're getting it by itself. All right, here, to get rid of this 4, we'd have to divide by 4. Here, we'd have to divide by 3. Here, we'd have to divide by negative 1 to get rid of that minus sign. So all the other ones we'd have to divide, and dividing is just, it's more likely to create fractions, it's more likely to lead to mistakes, so whenever we can avoid dividing, that should kind of be our goal. So what we're going to do is we're going to write this x plus 6 equals 3y. Then we're going to subtract 6 from both sides. We get x equals 3y minus 6. And now we have a letter by itself. The x is all by itself. So we can circle the 3y minus 6 because that's what x is equal to. And we're going to be able to plug it into this top equation for the x. All right? X is equal to 3y minus 6. So up top here, we can plug it in for x. We don't ever plug it back into the equation we started with. We plug it into the other equation. So it's going to go right in there for the x. So when we write that, it's going to be 4, and then because we're plugging in more than one thing, it's important to remember the parentheses. 3y minus 6 minus y equals negative 2. All right? Now we have an equation that we have to solve. All right, so we're going to start by distributing. 4 times 3 is 12y. 4 times minus 6 is negative 24. Minus y equals negative 2. Now we're going to combine our like terms. So we have a 12y and a minus y. So that's going to combine down to 11y minus 24 equals negative 2. Then we'll add 24 to both sides. We'll get 11y equals 22. We'll divide both sides by 11. And then over here, I'm just going to write y equals 2. Right? So there was a lot of work there, but again, we're not done. We still need to find our x. So we're going to have to plug this into one of our two equations. And again, it's your choice which one. Just try to pick whichever one looks simpler to you. So I'm going to go with x plus 6 equals 3y. So if y equals 2, this 2 is going to get plugged in right here. So I end up with x plus 6 equals 3 times 2. X plus 6 equals 6. So then when I subtract 6 from both sides, I'm going to get x equals 0. So x equals 0, y equals 2. And just remember, if I were to graph these lines, they would intersect at the point 2, comma, whoops, not 2, comma, 0, comma, 2. All right, the x comes first, the y comes second. So that's my x, that's my y. All right, now it's a little harder to check one like this because I can't put it into y equals as easily. But what I can do is I can just sort of plug the numbers in and make sure they both work. So the first one is x plus 6 equals 3y. So instead of x plus 6, I'm going to do 0 plus 6 and get 6, so that one checks. Instead of 3y, I'm going to do 3 times 2. Yep, both of them are 6, so that's good. Then on the second one, I have 4x, so that would be 4 times 0. Minus y, well, y is 2, so minus 2. And hopefully that's going to equal out to negative 2, just like it does up here. And it does, so that's kind of my check for these. All right, I can't really put them in the y equals menu, but I can just plug in the numbers and make sure that the two sides are equal. And in this case, they are, so we're good. All right, let's take a look at the back and the final question. Using substitution, find the intersection point of the two lines. Okay, so this one is actually a little easier than the last one because you're seeing that we have one of the letters by itself. The y is by itself here, so we don't have any extra work to do here. All we need to do is circle the 5x minus 13, and that's going to get plugged in for the y. All right, so we're going to take that 5x minus 13, and we're going to plug it in for the y in the top equation. All right, so what that's going to leave me with is 3 parentheses 5x minus 13 equals 4x plus 27. Right? Now I just have to go through and solve my equation. So I'm going to start by distributing. 15x minus 39 equals 4x plus 27. I've got variables on both sides, so I'm going to move the smaller variable. Minus 4x, 11x minus 39 equals 27. Okay, I'm going to add 39 to both sides. 11x equals 66. So if I divide by 11, I'm going to get x equals 6. Now again, I'm not done yet. I still need to solve for y. So you can pick either equation. In this case, I would say the y equals 5x minus 13 is probably a little easier. A little less work to do, but again, you can pick either. It doesn't actually matter. So this 6 is going to get substituted back in here. So y equals 5 times 6 minus 13. Y equals 30 minus 13. So y equals 17. So again, sound like a broken record here, but if we had two lines, they would intersect at the point 6, comma 17. That's what we're really doing here. And again, if you want to check this one, again, the y's aren't by themselves, so this is one that we might just check by plugging in. But if we look at the top one, all right, we've got 3y equals 4x plus 27. So 3 times 17, because 17 was our y, is 51. And then we're also going to plug in for our x. So 4 times 6, because that was our x, plus 27. And you're seeing that we get 51 and 51, so that's good. On the second one, we have y. Well, y was just a 17. And then we have 5x minus 13. So 5 times 6 minus 13 is 17. So you're going to see they match for the first equation. They match for the second equation. So we are good. This checks out. All right. That is the end of this homework. I hope this was of some help, and have a good day.